have to come up with a way of basically telling the person running the program, hey, stop and remove the clamp. And the way we do that is by creating a manual entry, and it looks like this. You can have a text, you can use a text file, you can have it output as a comment or as a code. I went with a code and just text entry, and I just typed in the code that I wanted it to do. I wanted to do a hard stop, whether or not the option stop is on. I want it to stop every time here. I want the tool to go up. It'll be at a tool change from the tool before. It'll be at a tool change, so it'll be from last tool it'll be up. So at this point it'll stop instead of going on to the next tool. And the table will shoot out, and this will hopefully be on the screen. Remove back clamp. So everything stops. The guy forgets about it. You look at the screen. Oh yeah, remove the clamp.
Okay.
And another MO. Cycle start, and I've got that in a couple of spots where we, here's the next one, put the clamp back on, remove the left clamp, and then put the left clamp back on, and then we cut, right after we rough out this front piece here, we're going to take off that front clamp, remove the front clamp, and remove the big chunk there. You might put, if you had some critical holes that tended to accumulate chips, you might put something like that in your program where maybe you had a couple tool operations that prepped a hole for boring. You wanted the hole to be real clean before you ran the boring tool in it. You might use this manual entry to I used to goof on the guys a little bit to see if they were reading. I put in there like blow chunks or, are you sure you're ready to go? Or, in a way though, it was kind of a check to see if they were reading it. I'd hear a guy, laughing or something over on the side. And the way you do that, so I'm just going to put one up here real quick, just to let's find my little red triangle here. So maybe I put one at the start, way up in here, just a little note. So what we're doing is we go to Toolpath, and if you do this we've got three little buttons here. The top one's not active at the moment. Over here in the 2D selection, I'm going to do the bottom button to give me the whole window of selections. And down here in the bottom left, it says Manual Ent. If you hover above it, Manual Entry. Directly insert text, comments, or G-code into your NC program. So I'm going to click on that, and this little window pops up. It's got stuff left over from the last one of my previous ones, but I don't necessarily need this. This is the very first toolpath, essentially, of the program. So I think to myself, what do we want to write? How about some little notes about where my work coordinates is, my PRZ, my WCS? So let's see, make some notes. You have to, before I start making notes, you got to think, do I want this as a comment or a code? Now you saw how I wrote the code. You just type in the code and they come out. So if I have code and comments, I might choose code, but when I write the comments, I have to remember to put the parentheses. But in this case, I just want to write some comments, so I'm going to put it as comment, and then anything I type up here, I'm going to say WCS, X0, Y0, as shown, C0, top of part, and I'm going to click green check button, and that's all you do. But, of course, I put it way down here. So let me That's right up here, right at the top. So now what I'm doing is see, what else should I show you? Oh, so I went through every toolpath. So the first step was creating the geometry, just drawing it. The second one was defining the toolpaths that we just looked at a minute ago. And then the third one, last night what I did is I went through this, and just to get me started, I used all of these settings for the tools. Now we actually added a second end mill that I called F9 tool 9 for tooling purposes, for fixturing, and that's the tool that we want to use for the back side and the left side. The reason being is we may need to offset those differently than the actual tool cutting the features, just so that we get a cleanup, because when we put that block in there, it may be, it's user defined, it's going to float in there. And I didn't want to have to put a bunch of offsets in the tooling and have it affect my actual feature. So I kept those separate. And that might be something that you run into out in industry too, is you'll have some redundant tools, but they cut on different features, so you have to keep track of them. Just for simplicity, on all of my tools, I clicked on Force Tool Change. Now, what the Force Tool Change does is if I have two tool paths that use tool 7, so I use tool 7 for roughing, and I use tool 7 for finishing. If this button is left off, it will, the code that comes out will start the first tool path and immediately go right into the second tool path. For our purposes, so we can kind of see it in the progression as it goes through, and it gives us an opportunity to rerun each section independently. If you click on Force Tool Change, it will make it stop in between tool paths. So, and you don't necessarily have to have it on every tool path. You have to have it on, and I forget, it's either the first one or the second one to make it work. But it doesn't hurt if it's on, and so to make it simple, I just turned it on everything. And that's what I would say. If you do that, if you turn it on everything, that ensures that every tool path is just going to run by itself and then stop at Z0. If rapid retract was available, I would toggle this. And some of them have plunge rate that you can override. I made all the plunge rates 10 inches a minute. Now these are drills and reamers, so we look at this one here. You see I've got rapid retract turned on, force tool change, and a plunge rate of 10. Now this is the other one. So if we look at our chart here, what's it say for tool 7? It gives us 14 inches a minute. So our little formula from the other classroom to reduce your feed when you're circular interpolating, depending on the ratio between the relationship between the size of the tool and the size of the hole, we're going to slow down our feed. How much do we slow down? Remember,
what was your question? What did you just ask?
Do you remember slowing down the tool for the circular interpolation from the straight line to the circular interpolation, the formula?
Yeah.
Remember the formula? It's So your feed in a G2 or G3 motion is going to be the straight line feed modified by the relationship between the hole and the tool. So if we take our hole 670 minus 500, divide 670 times our 14, we're going to get 3. So if you look at my settings here, settings here, 3 inches a minute, so that's how I got that. I did the same thing for the corner rounder. The corner rounder has a pilot of 375. So when I circular interpolate, instead of making a tool path for both sizes of holes, I just calculated it based off of the smallest hole, so 500. And that's how I reduced the feed for the circular interpolation of the holes using the corner rounder. Morning.
Morning.
So at this point, I'm pretty much set up. Let's take a peek at it and see how she looks. It's loaded. Let's do it by steps. There's spot drill, drill, circular interpolate to open, and finish, rough. Now when I rough the pocket, I think we're going full depth, but we're just not quite going all the way out to the outsides. And finish the pocket, corner around the pocket, corner around the holes, and that was the back side and the front side, or left side, back side and left side where we're cut. We're squaring these up. Remember, we're squaring these up so we can hold it in the vise and work in the manual mill to put those extra features in it. And there's our, oh shoot, clicked the wrong button. Okay, cut the left side. There we cut this apart. Remember there's that little manual entry where it stops. And then I'm going to remove this front clamp. I'm going to remove this big chunk out of the way and clear the chips out so we can go in there and make a nice cut for finishing in here. Now notice, see we've got a couple gouges here where the tool hits this chunk here. That won't happen if you remember to take this chunk out. If you don't remember to take it out, it'll get, it could get knocked around a little bit, which may or may not be a problem.
Is there a comment before we take that chunk out?
Mm-hmm. Yeah, so I call it a hard stop. Put a hard stop before the back edge is cut so we can remove this clamp. And then another hard stop to put that clamp back into place and remove this one and cut this side. And then another hard stop to put this clamp back in. And then it removes this material. And after it removes this material, another hard stop to remove this clamp and this big remnant. Call it a drop sometimes. There's a corner round, this inside feature. And then, lastly, we're going to come in and stitch this little piece in here. Now, about the stitching here, we can do it in two different ways. We can, we could start at the top, and we can work our way down, or we can start at the bottom and work our way up. I kind of favor starting at the bottom and work your way up. If you start at the top, I mean, it'd probably be okay either way, but if you start at the top and you're working your way down, you know, you're going towards where all the chips are at. It seems like to me, I kind of like the idea of coming up. At least that way, there's less, you know, possible, you know, milling into a pile of chips. If that makes sense. Okay, so let me show you how I created this little radius here. Okay, so let's start with the green. The green here, this is my part, and this arc is the same arc here. And if we look at it from the top, control it better. Hang on a second. Let's pause just for a minute. Oh, sorry, I'm without my buttons from the old version, so I'm handicapped a little bit. And I've got used to using the mouse where I pull it towards me or I push it away. So it's opposite what the defaults are. So sorry about that. Now I can do this a little more. So if we look at the top here, basically I've taken this top arc and I've pushed it out to the side. Now if I'm starting from the top, when you look down at it like this, if I was closer to the sides, it's going to gouge the material. It is going to remove the material and not hurt the part essentially, but it's going to cut the part as you're going straight in. That might be a benefit. We could shorten up this area that we're cutting by starting at the top and coming down into it. But since we're starting at the base of it and then coming up, I want to stay out to the side far enough. For example, if I envision there's some material over here on the left, and if I started this tool on the left-hand side, I'd be cutting into the part too. I want to try to stage the tool. I want to come to depth of cut before I actually start cutting. Okay. So the tool is a 1/2 inch, and so I went with 270. 250s spot on, and if it floats a little bit, I give myself a little room. I went a couple 20 more. So if we look at distance from here to here, it's 270. So I basically copied those arcs out, and then I took, this is the tangent line of where the arc starts and where the arc stops. If we look real close, I've got a little 50,000 straight line on there. So I don't want the tool starting to stitch right where the stitch begins. I want a nice blend. So I start a little bit before it. And then I'm going to finish a little bit after it. So what I did is I took this line and this line as marker points, and this one's translated 50 thousandths deep, and this one's translated 50 thousandths in the plus y direction. Then I just created this little straight line on the end of the arc. That's where I got this little straight line. Let's see, so by pushing this arc out both sides at 270, I can trim this straight line to that length. So this is the length. And the tool path, now I also did, just to keep it clear, you can see what I did here is I've got the top of it, this is my what's called the across. My across, you have to establish directions, and when you're chaining it, I didn't want to grab everything all at once, and so I separated them. So this is my across, and the straight line is the along. And that'll make sense here in a minute. So make sure your plane is proper. Got my levels here. Tool path. So I'll create another one here, right down here at the bottom. Tool path. And what we're looking for is a 2D swept. 2D swept. Click on that. And it's asking chain, define, across. So remember I called it across and contour. The across is the first one you're going to chain. If we go back down here to levels, notice how I have this state positioned. I've got this little menu bar positioned, and I can work this levels down below over here and keep track of everybody. So I have my across. Now if I clicked on the top up here, it's going to start on the top of the part and come down, as opposed to start at the bottom and go up. So you can flip around the sequences of them. But in this case, I'm going to go ahead and chain the top like this. That's going to drive the tool from the bottom up, like we were talking about. And then it says, select the new chain. So I'll come over here to my levels, and I'll switch the level views like this. And this is, and I separated the geometry by the levels just to make it easier to keep click on. So over here, I click on. Here again, if I clicked on the left side of this, it would start where all my excess of stock is at. But at the moment, that right hand, that chunk has been removed out of the middle, and so I want to start on the right where there's no material. I'm going to come in a clear spot, then start machining. Click here, click done, and it asks me for a start point. And I'm going to put it right here where like that. It's clicked, it shows up as a ball end mill, which is already, I've done that before, that's good. The only rules, so we're going to, actually the feeds and speeds popped up from what we have on the board. I have changed the plunge rate to 10, and just for simplicity, I turned on all the force tool changes and all the tools just to make sure we get a break in between tools. And rapid retract is on, so when it's done cutting, just move out. The only really other thing to change would be your cross cut here. I put 10. I put 30. Here, I'll make it a little more exaggerated. Show you how the difference, and that's the only change I'm going to do is put my cross-cut difference. Select OK, and go back to tool paths, back plot. notice how far apart the steps are. That's that number we changed on the second page. Open up parameters, make that, I chose 10, so it'll be a nice smooth transition. You're not gonna have to do a lot of handwork to it. See the difference? Now if we wanted to play with it for a minute, let me just click the save again. Yeah, just to show, okay, and if you mess up on the sequence of these, this particular toolpath is a little finicky to work with. And the best solution I found that if you